Hi guys, I'm Antoinette Salvador and I am here today to discuss to you about the definite integration. And now let's start.
If the function f is defined on the closed interval ab and is continuous in the said interval, then the function f is said to be integrable on ab and is denoted by
Integral of f of x dx from a to b. There is also a little bit of terminologies that we should get out of the way here. The number a at the bottom of the integral sign is called the lower limit of integral. The number b at the top of the integral sign is called the upper limit of integral. There's a theorem that if a function f of x is continuous on the closed interval ab and capital F is an antiderivative of the function f on that interval, then integral of f of x dx from a to b is equal to capital F of b minus capital of F of a. Now, let's proceed to the example. First, we have to find the antiderivative of x plus 1. So, the antiderivative of x plus 1 is equals to x squared over 2 plus x. Now, we have to substitute the value of 2 to the x. Then, we have to minus the value of negative 2 to the x. So, we have 4 minus 0. So, the final answer should be 4. So, here's some examples for us to understand well. So, we have here, first example, integral of x plus 1 dx from negative 2 to 2. So, first, in order to find the antiderivative of x plus 1, we have to use the general power rule. So, we have here the formula. The formula for general power rule is the integral of u raised to n du is equal to u raised to n plus 1 over n plus 1. So we have another example. Integral of 1 over x squared dx from 3 to infinite. In this example, the best thing to do to make it easier, we have to put the x squared to the top. Integral of x raised to negative 2 dx from 3 to infinite. Now, we have to find the antiderivative of x raised to negative 2. So, we have x raised to negative 1 over negative. So, I put the x raised to negative 1 to the bottom. Now, let's proceed Let's substitute first the infinite before the 3 based on the formula given. So we have negative 1 over infinite minus 1 over 3. So the final answer should be negative 1/3. Next example. Integral of tangent theta over cosine theta d theta from 2 to 1/2. In this example, you can use the identities in trigonometry. It would be easier for us to use the identities so that we can solve the problem. So now we have tangent theta. So we use the identities of cosine theta. So we have 1 over secant theta d theta from 2 to 1/2. So we have to multiply it. So we have integral of tan theta, secant theta, d theta from 2 to 1/2. So we all know that the antiderivative of tangent theta, secant theta is equals to secant theta. First, we have to substitute the 1/2. To solve for this, you can actually use calculator. So the final answer should be for the last example, we have integral of negative cos raised to 3 x sine x dx from 0 to 2 pi. In this example, we can apply the u substitution. So first, we have to know what is our u. So our u is the cosine x. we know that the derivative of cosine x should be negative sine x. So we have dx is equals to du over negative sine x. So here we substitute the value of dx, that du over negative sine. We can cancel the sine x. So we have integral of u raised to 3 du from 0 to 2 pi. So we have to solve for the antiderivative. We have u raised to 4 over 4. So we have to substitute the value of u, cos sine x raised to 4 over 4. So now let's substitute the 2 pi and the 0. So you can use your calculator for computing it. So the answer should be 1/4 minus 1/4. So the final answer should be 0. Please take note that in definite integration, the final answer have no constant c. And that would be all in definite integration. I hope you learned something, and thanks for watching.